What actually exists right between a massive black hole and the light trying to escape it? People try to tell you it's just a simple line in the sand, an invisible event horizon. They say one side is light and the other side is total darkness. Wrong. Not just a little wrong, fundamentally wrong. Between the total darkness of the singularity and the safety of the universe, there is a hidden, razor-thin trapdoor, a place where gravity is so perfectly balanced that light itself gets caught in orbit, an infinite glowing shell of trapped photons. You've actually felt a version of this. Close your eyes and imagine driving a car entirely too fast around a sharp, icy curve. You feel that terrifying split second where the tires are floating. You're not spinning out yet, but you're not going straight either. You are perfectly suspended on the edge of disaster. That's what happens to light. It gets stuck. If you stood in this photon ring and looked straight ahead, gravity would bend the light perfectly around the black hole. You would literally see the back of your own head. Let me show you. We are taught that black holes are cosmic vacuums, a one-way ticket to nowhere. But that is just a label, a lazy shortcut. To understand the photon ring, we have to throw away everything you think you know about space. Here's the part nobody tells you about gravity. It doesn't just pull. It twists and stretches the actual universe. Let's start small. Think of someone you know making a bed. Imagine pulling a flat, tight bedsheet across a mattress. Now, drop a heavy bowling ball right in the dead center. What happens? The sheet sinks. It warps. It creates a deep, steep valley. Now take a tiny glass marble and flick it across that sheet. If you flick it fast enough and far away from the center, the marble rolls in a straight line. It just dips slightly and keeps going. If you flick it too close, it spirals straight down and smashes into the bowling ball. But what if you hit the absolute perfect angle? Stop. Think about this. If your speed and angle are perfectly dialed in, that marble won't escape and it won't crash. It will just circle the rim of that valley, round and round and round. Now watch what this implies for everything you see. Zoom out. Make that bowling ball a dead, collapsed star holding the mass of 3 suns. Make the bedsheet the invisible fabric of space and time. And make that tiny glass marble a single photon, a particle of light traveling at 186,000 miles per second. People say light always travels in a straight line, but that's just a label. Light follows the shape of space. If space is curved, the light bends. This is exactly where your intuition fails, because when that space curves deeply enough, the light gets caught. It behaves exactly like that glass marble, perfectly balanced on the rim. It doesn't fall in. It doesn't fly away. It orbits. A glowing halo of light, perfectly suspended in the dark. But here is the catch. Our marble on the bedsheet slows down because of friction. In space, there is no friction. Light never loses speed. So it circles that dark abyss millions of times per second, forever. Or at least until something disturbs it. Because nature doesn't like straight lines, and it absolutely hates perfect balance. So what happens when you push that delicate balance just a single millimeter too far? Let's talk about that single millimeter. If you push our photon just a hair closer to the center, it slips. It plunges down the funnel. It crosses the line. People say the event horizon is a physical wall, but that's just a label. It's simply a math boundary, the point where the escape velocity becomes faster than light itself. Since nothing goes faster than light, nothing comes back, period. But right outside that invisible boundary, the rules get weird. This is exactly where your intuition fails. Imagine standing exactly 1.5 times the radius of that event horizon. You are in a zone of pure, absolute tension. On one side, the infinite pull of the singularity screaming at you to fall. On the other side, the momentum of light screaming at you to fly straight into the void. They match perfectly. Look, that sounds impossible until you see the trick. The trick is that space here isn't just curved, it is wrapped around the black hole like a tight ball of yarn. A photon arriving from a distant star flies in. It hits this wrapped space. Instead of passing by, it gets snatched, caught in a groove. It revolves. 1 time, 2 times, 1,000 times. A sphere of light trapped in an endless carousel of gravity. We call it the photon sphere. But here is a chilling thought. Try this. Hold your hand near a hot light bulb. You feel the heat radiating outward, right? Light wants to scatter. It wants to burst into the universe. In the photon sphere, it can't. It is a prison made of speed and gravity. If you were a photon caught here, you wouldn't feel the pull. You'd think you were flying perfectly straight. But space is bent into a perfect loop. You are trapped in a circle, convinced it's a straight line. Wait, if light is trapped here forever, why don't we see a blinding ring of fire when we look at a black hole? Why does it look like a shadowy donut? Because the photon sphere is deeply, terrifyingly unstable. It's a knife edge, like balancing a pencil on its tip. It works for a second, but any tiny jiggle ruins it. And the universe? It jiggles constantly. So how does this delicate ribbon of light actually bend our entire physical reality? Let's zoom right in and find out together, right now. Let me tell you about the time I first looked through a funhouse mirror. They warp your reflection. They stretch your forehead and shrink your legs. Now take that funhouse mirror and make it the size of a solar system. That is what a black hole does to the universe behind it. People say black holes are invisible, but that's just a label. They are actually the most powerful magnifying glasses in existence. We call it gravitational lensing. Don't blink or you'll miss the best part. When light from a distant galaxy travels toward us, it should travel straight. But if a black hole sits right in the way, that light gets dragged. It smears, it stretches, it bends around the dark edges like flowing water. You see twisted ghost images of galaxies sitting millions of light years behind the black hole. But closer in, right at that unstable knife edge, things get incredibly violent. This is the exact moment physics breaks. Remember that random jiggle? The universe is filled with random quantum noise, dust falling in, magnetic fields rapidly snapping. When a photon balancing on the sphere gets nudged by this noise, one of 2 things happens. It either falls inward, totally lost to the dark void forever, or it gets violently whipped outward, slingshotted directly toward planet Earth. Exactly. The light we eventually see from a black hole isn't actually light from the hole itself. It is the light that barely escaped the trap. It is the light that orbited 3, 4, or 5 times before being flung into our distant telescopes. You are looking at a cosmic prison break. Let me say that again because it's insane. Every single pixel of that glowing ring is a survivor, a photon that brushed against the literal end of space, spun around like a rapid top, and broke completely free. If you were the size of an atom standing right in that blazing storm, you would be absolutely shredded by the sheer force of it all. But what does this ring actually look like if you break it apart? If you neatly slice it open and look deep inside? It is not just one simple blurry ring. It is an infinite nesting doll of extreme reality. Rings inside of rings inside of rings. Each one holding a completely different, twisted snapshot of the entire universe. Wait. How can an infinite number of rings fit seamlessly inside a finite space? How does light naturally manage to trap an eternity of images into a single physical boundary vastly thinner than human hair? To understand that, we have to look far closer at the actual photon ring structure itself. Right now, follow me carefully. We are finally at the absolute core of the mystery, the edge of the black hole. The actual photon ring itself. So far, we've learned that light gets bent like a funhouse mirror, and that right near the event horizon, it gets totally trapped. People say the event horizon is a sharp, flat boundary, but that's just a label. It is actually surrounded by a blinding storm of chaotic, swirling fire, the accretion disk. Smashed up gas and dust burning at millions of degrees. But right inside that fiery disk, things go eerily quiet. There is a gap where gravity is so strong, matter simply can't orbit anymore. It plummets straight in. And directly inside that gap sits our photon ring. Here's the part nobody tells you about gravity. The photon ring is entirely made of light that was perfectly deflected from the surrounding universe. Imagine taking a flashlight and pointing it directly across the face of a black hole. Instead of passing by, the beam gets sharply bent toward the center. If the beam is aimed perfectly, it circles the black hole exactly once. It completes one 360-degree orbit and then flings back out toward you. This creates a distinct ring, a glowing circle on the night sky. But wait, that's just the very first ring. What about light that was aimed just a microscopic fraction closer? That light doesn't orbit just once. It is pulled slightly harder. It wraps around the black hole exactly twice. It circles 720 degrees before finally escaping and hitting your telescope. This creates a second, thinner ring sitting perfectly inside the first one. Now watch what this implies for everything you see. What about light aimed infinitesimally closer than that? It orbits 3 times, 4 times, 50 times. Each time light makes another orbit, it creates a new ring, exponentially thinner, tucked inside the previous one. You might say that's just a mathematical glitch. It isn't. This is the secret hiding in plain sight. You are looking at an absolutely infinite sequence of concentric rings. Each ring contains an image of the entire universe, sharply compressed into a razor-thin band of light, an infinite series of echoes. The outermost ring is a thick, blurry snapshot of the surrounding galaxy. The first subring is a sharper, thinner snapshot of the same exact galaxy. The second subring is an even sharper, even thinner snapshot, tucking tightly against the darkness, stretching forever inward. If you had a powerful enough telescope, you could zoom into this photon ring infinitely. You would see the same universe reflected back at you over and over, trapped in a mathematical paradox. But what if you were physically floating there? What if you were completely still, hovering right inside this infinite shell of light? What would you actually see? Let's put you right there. Imagine stepping into a glass elevator hovering exactly on the photon sphere of a perfectly still black hole. You are perfectly safe, not falling, not flying away, just balancing perfectly on that razor-thin knife edge. Look straight ahead into the blackness. People say black holes are completely dark spheres, but that's just a label. They are actually a distorted window into an infinite funhouse of trapped light. Here's the part nobody tells you about gravity. In this exact spot, space is warped into a perfect 360-degree loop. If you shine a flashlight directly forward, parallel to the event horizon, the light doesn't fly into space. It gets caught in the groove. It flies perfectly straight along the curved path of the universe. It travels 360 degrees around the black hole, and then it hits you directly in the back of the head. Exactly. If you turned off the flashlight and just looked forward, what would you see? You would see light bouncing off the back of your own spacesuit. That light would fly entirely around the black hole and enter your eyes from the front. You would literally see the back of your own head. Now watch what this implies for everything you see. Because space is wrapping light around the sphere in every single direction, it's not just a single beam. It's an entire shell of trapped images. If you look slightly up, you would see the top of your own helmet. If you look slightly right, you would see the right side of your own shoulder. You are completely surrounded by a perfectly unbroken sphere of your own reflection. But it's worse than that. Remember the infinite rings we talked about? That light doesn't just circle once. It circles twice, 3 times, 4 times. So when you look forward, You don't just see the back of your head once. You see it perfectly framed inside a smaller image of the back of your head, which is framed inside a smaller, sharper image of the back of your head. An infinite tunnel of your own reflection, fading endlessly into the blackness of the event horizon. This is exactly where your intuition fails. You are standing at the absolute limit of observable reality, and you are staring into a literal infinity mirror created entirely by the crushing gravity of a dead star. But nature hates perfect balance, and real black holes aren't perfectly still. They spin. So what happens when you take this delicate infinite mirror and spin it at millions of miles per hour? What happens to this perfect trapdoor when the black hole itself starts dragging the entire universe along for the ride? Let's find out right now. Because it breaks the shape of reality entirely, real black holes are chaotic engines. They are born from spinning stars that violently collapse, and they never, ever stop spinning. People say space is an empty void, but that's just a label. It is a physical fabric. And when a black hole spins, it literally drags the fabric of space-time with it. We call it frame dragging. Imagine stirring a giant bowl of thick honey with a wooden spoon. The honey right next to the spoon starts swirling at the exact same speed as the spoon itself. That honey is space-time, and the spoon is a black hole spinning at near light speed. This is exactly where your intuition fails. Because of this violent swirling, our delicate, perfect little photon ring is absolutely shattered. It can't stay a neat, tidy sphere anymore. If light tries to orbit against the spin of the black hole, it gets blasted. It gets forced outward by the sheer drag of space itself. It has to orbit much further away just to survive the ride. But if light orbits with the spin, it gets sucked violently inward, hugging the event horizon so tightly it practically scrapes the edge of oblivion. So the photon ring isn't the ring at all. Now watch what this implies for everything you see. It splits. It warps into an infinite series of wobbly, chaotic shells, a twisted three-dimensional cloud of trapped light, thicker on one side and paper-thin on the other. It's an absolute mess of orbiting photons. Here's the part nobody tells you about gravity. Because the black hole is dragging space, the light that reaches us is totally scrambled. One side of the glowing donut looks incredibly bright, while the other side is dim and faded. The bright side is light being flung violently toward us by the spin. The dim side is light fighting a losing battle against the current. This twisted shell of light is exactly what the Event Horizon Telescope captured in its famous images. That blurry orange donut wasn't just a picture of hot gas. It was the shattered, smeared ghost of the photon ring itself. But wait! If this shell is holding light that has orbited for years, centuries, or even millennia, what happens to all the information carried by that trapped light? Does it just spin around forever in the dark? Or does this ring actually act like a massive cosmic hard drive, storing the history of the universe right on the edge of destruction? Let's look at the ultimate trap, right now. Imagine trying to read a completely transparent piece of paper flying by you at light speed. That is what a telescope has to do to read the photon ring. Light carries information. It holds the complete visual history of the stars and galaxies it came from. People say light is just brightness, but that's just a label. It is exactly like a digital photograph. Every photon is a tiny physical pixel of the universe's memory. Now picture a photon born from a supernova that exploded 1 billion years ago. It flies through empty space for 1 billion years. It carries the image of that violent death. Then it hits the photon ring. It gets caught. It spins. Here's the part nobody tells you about gravity. That photon doesn't die. It just circles the drain. It orbits 100 times, 1,000 times, 1,000,000 times. While the rest of the universe ages and dies, that single photon is perfectly preserved, spinning on the razor's edge. This is exactly where your intuition fails. The photon ring is not just a glowing circle. It is a literal physical archive of the universe. Every single ray of light that ever grazed this black hole is trapped here, stacked infinitely tight. If you had a magical, infinitely powerful telescope and aimed it at the first subring, you would see the universe as it was a few minutes ago. If you aimed it at the second subring, you would see the universe as it was a few hours ago. Aim it at the millionth subring, you would see light that has been orbiting for thousands of years, a perfectly compressed movie of the cosmos, playing backwards into infinity. Now watch what this implies for everything you see. Because space is totally smooth, there is no limit to how many subrings can fit. You can fit an infinite number of rings into a space infinitely thinner than a single atom. It is a bottomless filing cabinet. But there is a catch. Because the rings are stacked so incredibly tight, they blur together. To a telescope on Earth, it just looks like one single solid band of light. You might say that's just a mathematical glitch. It isn't. It is an actual physical limit of the universe itself. So how do we actually prove this infinite archive exists if it's too small to see? How do we peel apart a ring of light thinner than an atom from 50 million light years away? Let's look at the ultimate scale of the invisible, right now. So how do we actually prove this infinite archive exists if it's too small to see? Imagine trying to count the dimples on a golf ball from Los Angeles, while the golf ball is sitting in New York. That is what astrophysicists are trying to do when they look at the first subring of a black hole 50 million light years away. People say scientists can just build a bigger telescope, but that's just a label. There is a literal physical limit to how sharply a telescope can see. A single dish on Earth can only see a blurry dot of light. Here's the part nobody tells you about gravity. To see the first subring, scientists had to turn the entire planet Earth into one giant telescope. They linked observatories across the globe to act as one massive lens. This is exactly where your intuition fails. Even with an Earth-sized telescope, the first subring is still a tiny microscopic smudge on the edge of the black hole. It's almost entirely drowned out by the blazing, chaotic storm of the accretion disk. The first subring is only 10% the width of the main donut of light. And the second subring? It's 100 times thinner than the first. The third subring? 1,000 times thinner. Now watch what this implies for everything you see. Even if you built a telescope the size of the entire solar system, you still couldn't see the third subring clearly. Even a telescope the size of the Milky Way galaxy would eventually hit a wall. Because the subrings are stacked infinitely tight against the event horizon. You might say that's just a mathematical glitch. It isn't. This is an absolute boundary of observable reality. We can literally only ever see the first 2 or 3 rings of this infinite tunnel. The rest of the universe's infinite memory is permanently locked away, trapped in a microscopic ribbon of light forever. So what does this mean for the nature of reality itself? What happens to all this infinite information when the black hole finally dies? Let's look at the ultimate deep truth, because this changes everything we know about space and time entirely. What happens to all this infinite information when the black hole finally dies? People say black holes last forever, but that's just a label. They don't. They evaporate. Slowly, over trillions of human lifetimes, they leak radiation, shrink, and vanish. So what happens to the photon ring? What happens to that infinite microscopic archive of the universe's entire memory? Stop. Think about this closely. As the black hole inevitably shrinks, the massive gravity holding that perfect knife-edge balance begins to weaken. The invisible trapdoor slowly, finally opens. The infinite rings begin to untangle. Here's the part nobody tells you about gravity. Those trapped photons, the ones that have orbited silently for billions of years, are finally set free. They fling violently outward into the cold, dark, completely empty universe. A final, blindingly brilliant burst of pure, ancient light. A delayed cosmic broadcast of a universe that doesn't exist anymore. This is exactly where your intuition fails. When you look up at the night sky, you aren't just looking at regular stars. You are looking at a vast, terrifying ocean of warped space, hidden funhouse mirrors, and deeply delayed echoes. It's not just a photon ring. It's the ultimate, indestructible memory of the cosmos itself, a perfect, unbreakable, infinite loop of light waiting patiently in the dark. And here is where it gets truly terrifying. Right now, at this exact fleeting moment, faint light bouncing off your face is traveling out into deep space. Some of it will travel for 1 billion years and eventually hit a supermassive black hole. It will get perfectly, permanently caught on that exact razor-thin edge. It will orbit 1 billion times, and long after our entire solar system is completely gone, a tiny, infinite reflection of you will still be spinning quietly in the dark, perfectly suspended on the absolute edge of oblivion. Now watch what this implies for everything you will ever see. Reality isn't just what you experience right now. It is every trapped reflection, every silent echo, and every bent ray of light hiding in the void. If you want to keep bending your mind around the true, terrifying shape of the universe, hit that subscribe button right now, because the rabbit hole goes infinitely deeper than just black holes. Look closer at the shadows. Never stop wondering about the invisible. I will see you in the next one, where we break reality again.